Hello there, this is Toby. I thought I would do a video, this time a lot more impromptu than usual. I'm working on figuring out how to reason about a program, the variables and the variable scopes of a particular program. I'm working with the Play programming language. If you don't know about that, I talked about it in my video called "The Dream of the Dream of the Time Machine." This is a very small experimental programming language that I am working with, and to give you an idea of what it looks like, this is some code in the Play programming language. I have written a parser for it. I have written a code generator for it to convert its AST to JavaScript. And right now, what I'm interested in is to implement closure in this language, which means that if I had like event listener like this, and the event listener needed to be able to access a variable that was declared outside of the function, in this case that would be cell here is the cell is declared outside of this immediate function, and therefore we're making use of a closure to sort of capture this variable, and make it available to this function even after sort of the outer function, in this case the main function, even after the outer function finishes executing. So it went to here and it terminated, but this inner function still needs to be able to access this cell variable, and closures is the mechanism we need in order for it to do that. And currently that does not work in the Play programming language, and I'm working on fixing that. But before we can do that, I don't think I have time today to go through the sort of actually fixing the whole problem, and we're gonna only tackle part of the problem. And the problem I want to tackle this time is just that I'm gonna figure out for each given function in the program what are the closed variables that it's having to access, and also where the variable is declared, as in, well, within this function, for example, there's two variables being accessed, if we don't count the functions as variable names. Although that's somewhat, we're going to simplify the problem and say we're not counting the function names as the variables. So there's two variables, event and cell. The event variable, well, it isn't even being accessed, but even if we did access it, that's not a closed variable because it was declared within the scope of this function. So we're cool there. The cell variable is declared outside of this function. Therefore, it needs to be closed. And actually, whenever that happens, the outside function needs to do something to preserve the existence of this variable for the purpose of this inner function. And at this stage, we just need to figure out what the set of closed variables is for each inner function before we can even sort of make the machinery work. So that is what it is. So in order to figure this out, we're gonna use AST Traversal techniques, which means, so if we parse this program, chessboard.play, I have a program called parse that will do that. What it does is generates this chessboard.ast file, and we can look at that file. So this is the AST of the chessboard program. It's a very deeply nested JSON formatted tree that represents the syntax in this program. And as you can see, each node has a type discriminator, which we can use to sort of figure out stuff about what this program is doing and what the programmer's intentions are. So we can actually figure out where all the variable references are, for example. Like it can find that, oh, that is a variable reference, that's a variable reference, and that is a function parameter, and that is a variable assignment, for example. I'll search for like variable reference. So in order to pick out all the variable references, all we have to do is just to loop through the entire tree and find a node whose type is var reference. Okay, so let's just go ahead and do that. I'm gonna write a little JavaScript function, or JavaScript script that goes through this tree using recursion, because this is arbitrarily deeply nested tree. I'm gonna try to pick out all of the variable, both the variable references and the variable assignments. Let's see how we can do that. I'm gonna make a new file. This is my second attempt. My first attempt was put in here, but I'm not gonna show you that. I'm gonna make a new file. I'm gonna call this I'm gonna call it colorvars. Let's do .js. Okay. So we're gonna run this guy in Node.js. So the first thing I'm gonna do is I'm gonna use the mz/file system. This is how I usually deal with a file system in Node.js. I actually do have a video about the mz library if you care to dig deeper into that guy. Okay, and this is usually how I do it. I have an async. I typically use async await for any kind of I/O, asynchronous I/O. I'm gonna main async function, and then if something goes wrong, I'll put the error into console.log so we can see it. Okay, so we're going to get a file name from the process object, and I think usually the file name comes in index number 2. For now, I'll print out the file name. So let me try running this code here, colorvars.js. I'm getting undefined, and that's because I need to supply a file name. While we're at it, I'm gonna say if you didn't provide a file name, I'm gonna not do anything, and you please supply a file name. Oops, didn't mean to do that. I meant to do that. Okay, so now if I did provide a file name, in this case, let's do chessboard.play. It'll get that the chessboard.play is the file name. Okay. Now I actually want to examine both the code file and the AST file. So we have the original code here and the AST file. I'll explain why that is. Basically, I want to actually color. I want to do syntax coloring. I want to like print out the code except with the variable names that are referenced. I want them colored using a little npm module called colors. This is one of my favorite npm modules, and it allows you to print colored text in your terminal. I want to also give props to Moo, which is the tokenizer library, which I'm using along with Nearly.js to build a parser for the Play programming language. And Moo is the library that enabled me to have all of this line number information. So lines, columns, and also offset. You can either use line and column or offset. Offset is the index number offset from the beginning of the entire file, okay? So I think we're gonna use offset for that. I'll show you a trick later to show you how I can do the syntax coloring. So for now, I'm actually gonna try to read in both the code file, this one, and the AST file. Let's see how we can do that. Okay, so the code file, let's just read the code first. So I'm gonna await fs read file, the file name. This will, if we await this will get us a buffer object, and we'll actually need to do toString to get it into a string form. And now if we print out the code, we should see the code of the program, and there it is. Okay. Now I actually need to get the I want to read in this AST file as well, and to do that I actually need to infer the name of this AST file based on the name of the program itself. And I can, to do that, I can just find the base name without the dot play. So I want to chop off the dot play from here, and then I will append .ast to the name. And the common way to do that is using, you could use actually a split, etc., or a regular expression to do that, but I commonly use the path library to do that, because the path library has a base name method like this, and I can say, although this API is not great, so this is saying, like, given that the extension, I already know the extension of this file is .play, can you give me the base name? And it'll give you the base name. So in the case of the chessboard.play, I will get chessboard as the result here, and then I'll append .ast to it to get the name chessboard.ast. So I'll call this guy ast file name, and then we'll also read in the ast. Okay, now again I'll toString it. This is not enough because that'll read in the contents of this file. I actually want to use the JSON parser to parse it, so then we end up with a JavaScript representation of that. So I'm gonna call JSON parse on that guy. There we go. Let me console.log the AST now, as well as the code. There's the AST. The way that console.log displays it, it stops displaying detail after a certain level. But if you really wanted to see more detail, there's this inspector function within the util library, which comes out of the box with Node.js. And so with this guy, you can do util inspect, and then you can tell it the maximum depth you want to display in terms of the details you want to see. So I say 10 to show a whole bunch of detail, and then you can see the console.log will show much more layers of detail for this program, and and this should be the same as what we're seeing in this file here. Okay, so now what do? We want to basically loop through this tree, but the word loop is not as it sounds, because we're not going to use a for loop or a while loop. We actually need to use recursion to, so to speak, loop through the tree, or perhaps we should say traverse through the tree, because a tree is a tree. At each level, it expands to multiple children potentially. And yeah, now I do have a utility traversal library that I have written recently, but I'm actually, for demonstration purposes, I'm gonna do this one from scratch, so that hopefully this will be more educational. So I'm gonna basically loop through. This is actually easy to see. Loop through each type of node. Okay, each type of node I want to see if it's a it will be somewhat tedious to do this actually, but let's do it. So I actually have to match, like I have to know about each type of node that I have in my programming language, and actually I have a very fast script which can tell me that information. So these are all of the types of nodes that I have in my programming language. We have a binary operation, Boolean, literal, program, return statement, etc. If we look at a more complicated programming language like JavaScript, it will have much more. It probably have 10 times or maybe even more than this. Okay, so basically I need to account for each type of these nodes. Okay, so let's go ahead and write a function called traverse. And let's traverse first. And traverse is gonna take a top level AST node. And in our case, let's open this guy back. The top level node is gonna be of type program. So I'll do sort of, this should probably be a giant switch statement that, yeah, let's make it a giant switch statement that switches on type of the node, and I need to basically account for each type here, and I'll do it sort of incrementally. And if I didn't match it, so I'll match case program first. That's down here because that's the first one it'll encounter here. And in that case, what I want to do is sort of traverse the statement within the program, and each thing, the statement is yet another array, or I should say an array of yet more AST nodes. So I can loop through the array, and then for each AST node in the array, I can call traverse on it again. So I'll do node.statements. So maybe like for statement, let statement of node.statement. I'll do traverse the statement again, and the statement is a node. Maybe I also call this node, call it child node. Also traverse that. But if it didn't match program, then the way I do it, so one way to do this is to do test-driven development, which means I write a test, and then I get the test to pass. Run the test, it fails, get the test to pass. At this moment, I'm a little, I don't know. I found that there are alternative ways to do that as well. And instead of doing like test-driven development, I'm gonna do like a pseudo test-driven development, which is that for the cases that I haven't written code to handle yet, I'm just gonna throw an error, and then it'll sort of tell me the existence of an error will sort of tell me what else I have to do next. So I'll say unhandled node type. And it'll tell me because it'll print out the node type that I haven't written code to handle. Okay, so let's see if I'm gonna try to traverse this node now. And yeah, for now, we're just gonna see if we can use this guy to traverse a node. And this AST, it starts at the program node. Okay, so this is the AST should be the program node at the top level. So let's run this file. See if that works. And now it tells us unhandled node type comment. So all right, let's handle comments. For comment, we actually don't care that much. So yeah, I'm just gonna break out of this switch statement because I'm gonna ignore comments. Okay, function definition. So case function definition. What are we gonna do with the function definition? Well, this is a function definition, and a function definition has a name. It could have parameters, but this one doesn't. It has a body, and a body is a code block that consists of more statements, which are more AST nodes. Okay, so a function definition, what are we gonna do? I think we need to loop through the statements within its body, so that would be that. And then that guy would have more statements as is shown here. So you dot body, and then you still have to do dot statements to deal with it. Another way to deal with this is maybe we could just pass the body to this traverse function, and then just make this traverse function know how to handle the nodes of type code block. I actually think I prefer that a little bit, because I kind of want this switch statement to have a case for every one of the node types. So I'm gonna do this. And yeah, now it's like, I don't know how to handle code block. Let's handle code block. Do I have to break out for everything? I do. I think I do. I'm supposed to break out. If I don't break out, it would actually continue to the next case and execute that too, and that would be really, really bad. So for the code block, I want to do something similar to this guy. Yeah, maybe identical to this guy actually. Okay, it's gonna loop through the child node within this statement array, and do the same thing to it, traverse to it. And now I have to deal with var assignment. Okay, so let's do that. Now the var assignment is something that we actually want to collect, because we're trying to color the variables, or either assignments to variables or references to variables. So let's keep that in mind. Maybe what we do is like have a results array passed in, although this is not and sort of when you find the nodes that you're looking for, you append to the results array. Although this is not a functional way to implement this, and but it is sort of easy to do it like this. So maybe I'll do it like this for now, and then later on demonstrate a more functional way to do it, which I would prefer. Like, I usually prefer more functional programming style of writing something. Okay, but for now, that's okay. But if we introduce a parameter to a recursive function, then we have to make sure that parameter is present in the recursive calls. So, and also the initial call. So let's say I'm gonna make a results. Okay. We're trying to collect good stuff that we find in this tree into this results, basically. And so if we pass in the array, the code in here is gonna push to this array when it finds the good stuff. But we need to be conscious of, or conscientious to make sure every time we're calling the recursive function, we also pass that guy in as the second parameter. Otherwise, you get some errors. Okay, and this is the case where, we find the thing we're looking for. Let's append it, or not append in JavaScript is push. Must be thinking Python. Okay, So we're gonna, we find a good thing, we're gonna push it into the results, and we don't need to recurse in the case of a var assignment. No, we do potentially need to recurse, because a var assignment, the right hand side of the var assignment could potentially have, like, for example, here, like this is a var assignment, and the right hand side of the var assignment could have other variable references, like this guy and this guy, for example. So we do need to recurse in this case, even after finding some good stuff. So I think what I'm gonna do is, and perhaps actually I know a var assignment there, it has a var name. Its var name is yet another node, is a node of type identifier. So I'm actually going to push its var name instead of pushing the var assignment. And I know that var references the other thing I'm looking for. The other thing I'm looking for, the var reference, which is something like this. You're just referencing the variable. Var reference also has a var name, which is also a node of type identifier. So I think what I'm gonna do to make my life a little easier is, in both cases, I'm gonna put the var name in the results array. So it can, later on, the code that needs to deal with it can just deal with one type of thing. Okay, so now I'm gonna recurse. So the var assignment node, let's look at another var assignment node. A var assignment node has a var name, but the thing we're gonna traverse again is the value, something like this. But this actually has a simple value, but some values can be complicated and have more var assignments, or not var assignments, but var references in it. So I'm gonna note that value and traverse that. Okay, so that's another recursive call. Let's run that and see what else we have to handle. Oh, call expressions. So let's do that. Excuse me. Okay, what does the call expression look like? Let's search it in this file. Well, call expression is a function call of some sort. In this case, it's a function call to the append to function, right? What's a call expression? Well, a call expression looks like that. It's a function call. And so it's got arguments. The things that you are passing to the function, they're called arguments. And we actually need to loop through those because the arguments could have var references in them and could also potentially be more complicated. So we're gonna loop through the arguments. So let's make a for loop. Arg. I'll call it child node because I called it child node in the other place. No, this time is arguments, not statements. And then I'm gonna traverse I call this code node for some reason. It should be child node. Results. Okay, so we're gonna recurse and traverse through the arguments. Argument, it should be arguments plural. Okay, now string literal. Okay. We need to handle string literals, but there's nothing to do with string literals because they are simple and they don't have any nested AST nodes within them. So I'm gonna just ignore that one. And then our var reference. Var reference is actually another thing we care about. So we're gonna add a result. I know it has a var name because I already looked at it. It has a var name which is going to be another AST node of type identifier. Okay. What else? What else? Do I need to traverse? Do I need to sort of recursively traverse stuff inside of a var reference? Well, no, because a var reference is simple. It's always just a identifier name like that, and there's no compound expressions within the var reference, so we do not need to recurse and call traverse again if we find a var reference. Dictionary literal. In JavaScript, this would be called object literal, but in my language, I chose to call it dictionary literal. So this dictionary literal is something like this. Do we need to recursively traverse? Yes, because a dictionary could have entries in it, and then the values within the entry, the keys, I think we've forced it to only be strings. Same as JavaScript, but for the values, you could potentially have more complicated stuff like another var reference here, or even arithmetic operations here if you want to. So we do need to recurse. Let's look at, so a dictionary literal has entries in it, and each entry is yet another array, it looks like, of length 2. So this is the key, and this is the value, I believe. That's how it works. So we're gonna need to loop through the entries of a dictionary literal. Let's go ahead and do that. And because this entry I know is, that should be curly brackets. I've been coding in play too much, and because in play it's the square brackets. Okay. All right, so an entry is an array that has 2 entries in it. The first entry is the key, the second entry is the value. Let's get the value out. I'll call it entry value to be very, very explicit. I don't think I need to recurse through the key, because the key can only be a string literal. And we don't, as you can see, we don't, well, I could do both actually. Let's do both just in case. Oops. So this is the entry value, and then the key value, or entry key, is entry at 0. And then let's go ahead and traverse both of them. Pass in the same results variable. Okay. And then for loop. Okay, let's do for loop. So for loop, what does for loop look like? For loop looks like this. It has a loop variable. So for loops in play looks like for something in something. This loop variable is going to be a reference or an identifier directly, actually. I think I'm actually going to put that into the results. Loop variable. And we also need to recurse. The iterable is this thing. Maybe we should have called it subject, but this thing we're iterating. It must be an iterable thing, so it's the thing we're iterating. We're attempting to iterate. And that could be more complex and could have more variable references in it. So let's go ahead and traverse that as well. But then there's more, because a for loop has a body nested within it, which is just another code block. So, and we already know how to deal with code blocks. So what I'm gonna do is just traverse node.body, and that should work out, I think. Number literal is another type of node we need to handle. This one is lazy because we can just ignore this one. It's not going to have any variable references within the number literal. If statement, Okay, let's look at an if statement. Okay, an if statement, let's see, has a condition which we need to recursively traverse, and it has a consequent, which is a code block. If the condition was met, it's gonna execute this consequent code block. So I need to traverse that. It could optionally have an alternate node, which could be yet another if statement or simply a code block, I believe. So in any case, we need to sort of recursively traverse through all three of these things within an if statement. Let's just go ahead and do that. Node condition and the consequent and the alternate. Try that. Okay, now it's binary expression. A binary expression is like, where is it? Oh, it's like this. Something operator something else, or something operator something else. These are binary expressions. We just need to traverse both sides, and those two sides are, I think, binary operation. Those two sides, they are the operator. We don't have to traverse because I know that's not gonna have var references in it, but the left hand side and the right hand side could. So I'm gonna traverse left and right. Okay, binary operation. Oh, I wrote that wrong. What? Did I still write it wrong? What's going on? No, it looks like I wrote it right. Oh, I didn't break here. Always remember to break. I don't. You can probably see I don't usually use switch statements. I don't know why I chose to do that in this video, but usually I prefer to use if statements instead of switch statements. But you know, you gotta try different things. Okay, so if you're using a switch statement, you want to make sure you remember to break after every case statement. Okay, so indexed access. What's an indexed access? An indexed access is something like this. You have something like, it's an array or a dictionary. You want to access one of its members using a key or an index number. That's an indexed access. So an indexed access has a subject, which is the thing you're accessing, and then it has an index, which is the thing you're using to index into the subject. So we need to recurse through both of them because each of them could potentially be a variable reference or something more complicated. So subject. There. Did I misspell that again? Indexed. I also forgot to break as well. Is that why? What? Oh, we have something that's undefined. I guess we could say if something is undefined. I think that's the case where if statement, the alternate is sometimes undefined. I can do this. Okay, yep, that did it. That's the alternate is the else clause of an if statement, which is optional. That's why we got when note that alternate was undefined and we traversed it, we had the node being undefined, and then it broke here when we tried to reference the type of the thing that's undefined, basically. But now we fixed that. Now function expression. We need to. A function expression is a what's a function expression? A function expression is an anonymous function expression. Yeah. So in that case, we actually need to go into the body of that function expression. Yes, I believe we do. We also need to go into the parameter list as well if we want to count those as variable names, which I think we do. So let's go ahead and do that. Let me think. Okay. So we need to go through, well, its body is easy. It's just a code block, so we can just, we already know how to traverse code blocks. But in addition, I need to go through the functions parameters. Yes, parameters. So from node.parameters, and we actually need to do a for loop to loop through it. Let me put a break here before I forget. I'll call this param of no parameters and traverse. Okay, let's see that happen. And now we need to deal with identifier. I think I'm actually gonna ignore it, because if we were to collect it, it would already have been collected in the one level up. So I'm just gonna ignore it, and that appeared to work, maybe. So after this traversal process should have iterated down the tree and visited all the nodes in the tree that needed to be visited, and hopefully collected all the variable references and variable assignments. And it should have pushed the results to this array. Let's display this array. Yeah, that's a lot of identifiers, and with their line location information too. Or you can either use this location, the line and the column, or the offset to do stuff with it. What I want to do is to color the variable references. And there's a trick that I learned from this npm package called Falafel. Falafel was created by Substack, extremely prolific member of the Node.js community. I actually used Falafel to do various things in the past, to do code rewriting in JavaScript. And one day I cracked open the source code of Falafel, and I learned this trick from Substack of how you can rewrite source code in a programmatic way using the intelligence from its AST. So I'm gonna do that trick now and explain that trick. Okay. So what you do is you take the original source code, which is one giant string, but you convert it into an array. Okay. So actually, I'm getting out my drawing pad here. Sorry for being ill prepared. Oh shoot, where is my, oh, I found it. Okay, so basically, oops, that's my house drawing. Okay, all right, so let's say you have a string that was like, I don't know, const, oops. Well, let me write an example in the play programming language. So it might just say name equal Toby. Let's say that was the string. I have double quotes around double quotes. What am I gonna do about that? I think maybe one thing I could do is just change the color of the double quote. Okay, this is the outer double quote is in red. Okay, so this is our string, and the trick is you split. You split basically something like split on the empty string, which will allow you to have an array of each individual character of the string. So you have N, A, M, E, space, equal sign, space again, double quote, T, O, B, Y, finally double quote. So you basically split this string up and convert it into an array which mirrors the string itself. And in a lot of respects, it can be treated as the original string because the index numbers are the same, right? This 0 index is N, index 1 is A, index 2, etc. You have the same indexing in this resulting array. Why did we do that? Well, if we wanted to replace some part of this string, say I wanted to, whenever there's a string literal, I just want to replace that guy with, or you know what? Let's replace the variable name. Whenever there's a variable name, I want to replace it with foo. I want to do, maybe, I want to rename all variables to foo. How would I do that? Well, the trick here, again, I have to give credit to Substack for this trick. I'll label this drawing Substack's code rewrite trick. The trick is you find the range of the original symbol, original sort of AST node. So currently, the AST node has that range, okay? And I know it's probably a identifier node. And the range is 0, 1, 2, 3. So the offset is the start offset. It starts at the index 0 of the entire string, and it ends at index 3 of the entire string. So if I wanted to replace this name variable with the string foo, what I can do is just go into this array, just cross out the first one, just stick the string foo in there, and now I replace each one of these guys with empty strings. Okay, so like every character except for the first one, or at least within this array, every cell except for the first one has been knocked out and replaced with empty strings, except for the first one where you put the replacement you want to use. Why does this work? Because at the end of the entire process, you take this array and you say dot join with the empty string again, and then that's how you get the new newly rewritten code. And then the result will be what you would expect. The result of this join will be foo equals Toby. Oh, let me put a different color on the outer double quotes. We will get this result, and that is Substack's code rewrite trick. Okay, so we're gonna implement that, see how it goes. All right, so the first step is I'm actually maybe call this the code string. No, I'll leave this. I'll make a code array, which to get the code array, all we have to do is split using the empty string. Let me show the code array instead of the results. So this is the code array. It's a big, huge string containing single characters in it. So that's step one. And the step two is, well, we got these results. So let me show the results again. Okay, these are the results. All the results are AST nodes of type identifier. And all of them have an offset that we can use. So we can say, we can write a replace function to replace the code within the, perform the replacement scheme as I drawn out here within this code array. So I'm gonna write a replace function, and replace takes an AST node as the first argument and the replacement string as the second argument. Okay, and it's gonna need access to the code array. Let me put that in also as a parameter. So given the code array, it's gonna take the start offset. How do we get the start offset, the start index? Well, each one of our AST nodes, courtesy of Moo.js, has this offset number, and each node has a start offset number and an end offset number. So I can say node.start.offset. That's the start index, and that's the one where we're gonna just replace with the replacement. But we're not done because we need to set the next characters to empty string to sort of erase the original, because we just took the first cell to store the entire replacement. Okay, and the reason I just want to make explicit that the reason we're doing this scheme is, if with this scheme it doesn't matter that there's not enough room to store every character of the replacement. If the replacement was really long, it doesn't matter. It's just stored in one of the cells instead of spreading the characters within these cells. Okay, so in addition to doing this, we also need to do a loop through the rest of the cells of the array and replace them with empty strings. So let's do let I equals start index +1, and the end index is node.end.offset. And so the end condition is as long as I is less or equal to end index, I believe, we're gonna replace that guy with an empty string. Okay, and then after that, the newly rewritten code, I'll call that new. Oh wait, I need to loop through the result and call replace. I'm gonna replace the result, which is one of the AST nodes, with foo. Okay, that's gonna be interesting. And after I've done this, I would, and I need to pass in the code array as well. Okay, after we've done this, the code array should have been modified in some way. Let's see if we can see that if we printed out the code array. Oh, we can see we have most of the contents of the array is still single character, but you can see foo here sometimes, and after foo we got these empty strings, which seems correct. So at the end, you just do a join on the code array to get the new code. And now let's print out the new code. Okay, that's the new code, and all the variables are called foo. Oh, I think I have a index off by one error here, so perhaps that needs to be less than, not less than, equal to. Yep, okay. I think I fixed that. I just renamed all of the variables to foo. Oh wow, that's amazing. But okay, so that's really cool. Just with this simple trick, which I learned from Substack, we were able to do these massive code rewrites automatically. This is automated code rewrites. You can actually imagine doing code translations, like you're migrating from an old version of a framework to a newer version of a framework, and every time you do something, a specific thing, you have to do it in the new way instead. You could actually write a tool like this that does Ast Traversal and intelligently automatically rewrite the code. But what I actually wanted to do in this exercise is to do coloring of the variable names. Okay, so how are we gonna do that? Well, we're gonna use the colors module. Okay, the colors module. Colors module has two ways of using it. I prefer the safe way, which doesn't muck with my string prototype and add a new sort of API to the string itself, because I'm paranoid, or perhaps purist. Okay, so I'm gonna use the safe way, which involves calling colors.green or colors.underline, etc., depending on the color you want. The available colors are these for text colors, but you can have a bright version of the text colors. You can also change the background colors. You can also do styles such as italic, underline, apparently, and there's some extras which are fun. So what I'm actually gonna do is instead of replacing all the variable names with foo, I'm gonna replace all the variable names with the colorized version of them. And for fun, I'm gonna use rainbow color. Excuse me. Excuse me. Okay, and because I know the result is of type identifier, identifier nodes in my language always has a value, which is a string. So I'm gonna get the identifier.value. I'm gonna rainbow color that guy, and then that will be the replacement of the original. Let's see what happens. Oh wait, colors, plural. Oh my god, that's amazing. That is freaking amazing. How is that for syntax highlighting? Okay, so this is cool. You can imagine doing different things, such as coloring different types of syntax differently. And my goal is actually to color the variables declared within different scopes differently. So I'm actually planning to use a sort of a color coding scheme, so that the variables that were defined in the main function, for example, I will color one color, but the variables defined inside of this scope, in the for loop scope, I would color in a second color, and within yet another nested scope, I will color that yet a different color. That is my plan. Yeah, I think this video has sort of I'm gonna take a break for now and come back to this, but so far we have made pretty good progress.